Okay, so today we are going to discuss the topic electric field lines. So we are going to discuss what does electric field lines mean, how to represent electric field lines, what are the properties, how to solve questions. So electric field lines are basically a way to represent electric field in a region. Okay, it's basically a pure geometrical construction, and in simple language, if I can explain, so if there is a charge q, and if you put a minus q charge here, so this charge q will attract this charge, correct? Because positive attracts negative. So something must be coming out from this charge and reaching to this charge, so it will experience force. This something is called as electric field. Okay, so conventionally, if you want to find out direction of electric field at any point, you have to put a positive charge at that point. Suppose I put a positive 1 coulomb charge here. So this positive will repel this positive. So the force will be outwards. So electric field will be outwards. And suppose there's a negative charge here, and if I put a plus 1 coulomb charge here, so it will get attracted. So electric field will be inside the negative charge. So for a single positive charge, electric field is outwards, and for a single negative charge, electric field is inwards. Okay, for single it will be radially outwards. So here the word is important, radially. So for positive outwards, for negative it will be inwards. Also for MCQs you can remember this thing, that for a positive charge, direction of force and electric field is same, while for negative charge, direction of force and electric field is opposite. Okay, so coming to the properties now. So property number one. See, electric field lines can never form closed loops. Okay, so if somewhere electric field is given to be, like this, can this be electric field line? No, because it is a closed loop. Electric field line can never form closed loop. Electric field line starts from positive charge, and if there is a negative charge nearby, so electric field lines will end at that negative charge. So it will start at positive, it will end at negative. It will start at positive, it will end at negative. There can be no closed loops for electric field lines because it will violate conservation of energy principle. Suppose electric field line form closed loop. Suppose. So if you put a positive 1 coulomb charge here, suppose, so it will continuously experience force and its velocity will going to increase till it reaches infinity. And this will violate conservation of energy principle. Okay, coming to the next property. Crowded lines represent stronger field, while weak lines, while distant lines represent weak field. So, and also the more the magnitude of charge, the more dense will be the electric field lines. So in this figure, there are few electric field lines, there are more electric field lines, and there are much more electric field line. So magnitude of charge C is much greater than B and much greater than A. So the more the value of charge, the more denser will be the electric field lines. Okay, and next property is like, if electric field lines are close, so value of electric field will be stronger, and if electric field lines are far away, then value of electric field will be lower. So denser the electric field lines, more will be the electric field, and further the electric field lines, weaker will be the electric field. In this figure, like for positive charge q, there are few electric field lines, but for this minus tq, the number of electric field lines are more. So value of electric field is also more here, and the value of charge is also more here. Okay, next property. Electric lines can never intersect each other. Okay, suppose at a point electric field has two directions, and if I put a 1 coulomb charge here, so a charge cannot travel in two directions simultaneously. So at a point there can be only one direction of electric field. So if there are two electric field lines due to two charges, then they will combine with the help of vector algebra, and there will be only a resultant electric field. At a point there can be no two electric field lines. Okay, this topic is used for just for identification. So if lines are straight and equidistant, then it's a uniform electric field. And if lines are not straight, even if they are equidistant, but this will represent non-uniform electric field. So for uniform electric field, they should be straight and they should be equidistant. Okay, so if I ask you if this is a uniform electric field, no, because the distance here is more and the distance here is less. So this is not uniform electric field. So coming to next property, tangent to electric field line at a point will give direction of electric field. Okay, suppose electric field line is like this. So if I want to find out what will be the direction of electric field at this point, so at this point just draw tangent. If I want to find out the electric field at this point, just draw a tangent here. So tangent to electric field lines will give direction of electric field. Also, the next point is very important, that electric field lines are smooth curves. They are differentiable at every point. Suppose if I ask you, can this represent electric field? No, because at this point, at this point, at this point, it's not differentiable. Okay, so electric field lines are smooth curves. So can this represent electric field line? Yes, because the lines are smooth. You know, the electric field, you can draw tangent at any point. At every point you can draw tangent. So it should be differentiable at every point, and they are smooth curves. Okay, this next property is important for charged conductors only. Suppose there is a charged conductor and there is a positive charge spread on the surface of the conductor. So remember one thing, electric field will always be perpendicular to the surface. At every point, electric field lines should be perpendicular. You know, if I draw electric field line like this, it will be wrong. Okay, the reason being, suppose electric field is E and this angle is theta. So there will be a tangential component called as E cos theta. And we are talking about electrostatics. There is no movement of charge, but this component will try to move the charge. But since charge is not moving, so this component is 0. So cos theta is 0 means theta will be pi by 2. So it will be only be possible if angle is 90 degree. So always remember that electric field lines are perpendicular to charged conductors. Okay, these are the properties which are important. Close to, we have discussed around 5 6 properties, and you have to remember all of them even for your CBSE board exams or IIT JEE or NEET exams. So in this figure I have put from taken from NCRT. So you have to find out which electric field lines are correct and which are not correct. So for this figure, so the charged conductor, it will not be correct. The reason being, the electric field line is not perpendicular at this point. You can take some time to think about this and then come to the solution. Like I'm giving the solution, you take some 2 3 minutes and then find out and then check whether you are right or wrong. So for next figure, see, electric field line start from positive, there is correct, it's correct. Electric field line ends at negative, correct, but this electric field line is starting at negative charge, so this can never be correct. C is correct. E, see, it is wrong. The reason being there are closed loops, so it's wrong. Electric field lines can never form closed loops. And here you can see it's very easy. The electric field lines are intersecting. So if they're intersecting, so it's not correct. So there is only one correct, this one. Coming to the next figure, you can take some time, for these two figures, and you can discuss the solution with me also. You can pause the video and you can check whether you can find the answer, and you can then ping me on my number, on my WhatsApp number, to know the solution. Okay, so here I'll tell you, this one is the correct answer, the C1. See, A cannot be correct because electric field lines are perpendicular to every point on charge conductor. Here it is not perpendicular, it is wrong. In a charge conductor, electric field is 0. So this one is correct, wrong. And here the electric field lines are not perpendicular. So this is also not correct. So this is the correct answer. In this figure, the correct answer will be 4. Okay. So you try to figure it out, like why other are not possible. Similarly, in this figure, there are 3 questions. So all these are from IIT, JEE or NEET exams. You try to solve these questions, and if you have any doubt, you can call me on this number or you can ping me on my WhatsApp number. My WhatsApp number is, I'm just writing it down here. So my WhatsApp number is, you can ping for the answer, 98675 30456. Okay, thank you people. Bye bye.